In lesson IA4, a continuation of the study of radicals, we're going to add and subtract radicals. And I have a little blurb written here that says to add and subtract radicals, the radicands, that's the number on the inside, and the indices, which is plural for index, that's the little number like a little 2 that is in the crook of the radical, must be the same. You will then add or subtract the coefficients. And that's literally all we have to say. If they're not alike, if they don't share the same index and they don't share the same radicand, then we simply leave them with the plus or minus sign between them. For example, problem number 1, it asks us to add 2 times the square root of 7 plus 6 times the square root of 7. Now these are what we call like radicals. The indices are both invisible 2's because they're both square roots. The radicands are both 7's. So I will add these two by adding the 2 and the 6 for 8, and it is 8 square roots of 7. And that is literally all there is to it. Number 2. In this problem, first I check to see if they're like radicals. Yes, they both have a radicand of 13x. They are both square roots, so they are indeed like radicals. So I know that I'm going to have some square root of 13x's. Now how many? I have 4 minus 8, which gives me negative 4 times the square root of 13x. Now things begin, of course, to get a little more advanced in the problems to come. Off to the side, I'm going to do a little work and then I'll put it under here. Right now, as you look at problem number 3, these are not like radicals and therefore cannot be added. But there is a possibility that you can do some simplifying. I won't always title this, but that's what I'm doing over here to the side. I'm going to take the square root of 27 and just think about it, not think about anything else in the problem. That is there a perfect square factor? Yes, it is square root of 9 times the square root of 3. The square root of 9 is rational 3 times the square root of 3. 4 times the square root of 3, which is the second term, cannot be simplified. So this problem becomes 3 times the square root of 3 plus 4 times the square root of 3. Now they're like radicals. The problem was rigged. It won't always be like radicals. So I'm going to have some square roots of 3. How many am I going to have? I'm going to have 7. In problem number 4, I'm supposed to subtract, and the radicands are not the same, so let me take a minute to come over here and simplify. I'll just abbreviate that. So I'll start with the square root of 75x. Well, can I simplify that? 75, is there a perfect square that goes into 75? The answer is yes, it's 25 times 3. X, it is not a perfect square, but nor can it be broken up, so it will stay over here in the non-perfect square radical. That gives me 5 times the square root of 3x. Then I have the square root of 27x. If you want to bring this sign with it, you can. I usually don't. I take care of it over here when I bring the simplified version back. All right, simplifying means looking at the factors. 27, yes, that is 9 times 3. I can't do anything with x, so it stays over here in the non-perfect square radical. That gives me rational 3 times the square root of 3x. So I can replace each of these, the first one with 5 times the square root of 3x minus 3 times the square root of 3x. Because the problem was rigged so we could do this, they are both square roots of 3x, and I have 5 minus 3, which gives me 2. That's my difference. All right, number 5. Right now I'm supposed to add these, and I can't because they're not like radicals. So I'll look at the first one, 4 times the square root of 32. Now, because I've done this for a very long time, immediately when I think about 32, I come up with the factors 16 times 2. But many people would not come up with that because they don't do this on a daily basis. So I'm going to write something, but then I'm going to erase it. I'm just going to pause for a minute and say 32. Well, I know that the perfect square 4 goes into it 8 times. But 8 has a perfect square in it. It's 4 times 2. Remember what we said earlier, the product of perfect squares is a perfect square. 4 times 4 is 16. So now I'm going to erase this. I'm going to keep this coefficient 4, and 32 can be broken down into that perfect square of 16, and 16 goes into 32 2 times. That means I have 4 times rational 4 times the square root of 2, or 16 times the square root of 2. All right. Now I have 6 times the square root of 50. Keep the 6. It's just kind of a tag along. Can you think of a perfect square factor that goes into 50? I hope you are thinking of 25 times 2. It must be a perfect square. So it's 6 times rational 5 times the square root of 2, or 30 times the square root of 2. Let's bring both of these over here. So underneath the first one, it is 16 times the square root of 2, plus underneath the second one, it is 30 times the square root of 2. You are not guaranteed always and forever that you will get like radicals, but you do many times in these academic problems. So square roots of 2, I have 16 and 30. Add them together for 46 times the square root of 2. All right, we're just going to continue with this. Move this over a little. All right, I have 4 terms. Right now, none of them are like terms. But let me see when I simplify, if I can, if I will get some like terms. All right, the first one, I have 3 times the square root of 8. That's 3, and let's see if I can simplify the square root of 8. It's 4 times 2, so 3 times the square root of 4 times the square root of 2. That's 3 times the square root of 4 is rational 2 times the square root of 2, or 6 times the square root of 2. Next, the square root of 32. Remember, I choose not to bring the sign with it. You can if you want to. So I just worked with the square root of 32 a few minutes ago, and remember that it's 16 times 2. That means I have 4 times the square root of 2. Next, I have 3 times the square root of 72. All right, I'm going to do a little writing and then I'll erase it because I want to work with 72. The first thing I thought of was 9 times 8, and that's a perfect square. But 8 has a perfect square in it. It is 4 times 2. Our little rule, the product of perfect squares is a perfect square. That means 9 times 4 is 36. Keep the 3. Square root of 36, and it goes in there 2 times. So that's 3 times 6 times the square root of 2, or 18 times the square root of 2. I have one more radical to simplify from the problem way over here on the left, and it is the square root of 75. I think I've worked maybe with the square root of 75 before. It is 25 times 3. Square root of 25 is rational 5 times the square root of 3. Now let me see if I can bring each of these back. It's going to go off. There we go. This is equal to, I have 6 times the square root of 2, subtract, 4 times the square root of 2, add, 18 times the square root of 2, minus 5 times the square root of 3. All right, these are not all like radicals, but many of them are square roots of 2. So I have 6 minus 4 gives me 2, plus 18 gives me 20 square roots of 2. And then I don't have any like radicals for this one, so I just write minus 5 square root of 3. Now, I don't throw this work over here. I don't throw it away. I keep it available so I can double check things. All right, number 7. Those are not like radicals, but here we go. I have the square root of 80. I think I'll do my work that I will erase. 80. I know 4 goes into it, and it's 4 times 20. I don't think that's the largest perfect square, but it is a perfect square. Then 20, I know that it's 4 times 5. You don't get to factor just any way you please. It must be a perfect square. That means that I have a largest perfect square of 4 times 4, which is 16. So this is the square root of 16, and if you divide it, it goes in there 5 times. So this is 4 times the square root of 5. Now the other radical is significantly larger. I'm going to do some work that I'll probably get rid of. I can't think of a perfect square that goes in there. But I think I will go ahead and divide it by 5 and see if that helps me. 5 goes in there 49 times. You could grab your calculator. I knew it was divisible by 5, and I know 5's not a perfect square, but I was hopeful that maybe the other factor would be. So I got my calculator and divide that by 5, and it goes in there 49 times, and that's my perfect square. So I worked a little backwards on that one. I'm sorry for the sniffles. I have the square root of 49 times 5. Square root of 49 is 7 times the square root of 5. So I've simplified both of these. This is equal to 4 times the square root of 5, subtraction sign, 7 times the square root of 5. I'm going to have some square roots of 5. What am I going to have? 4 minus 7 gives me negative 3 times the square root of 5. And you can see why it's so important that you be able to simplify radicals. That's the only way you can add and subtract them. This one involves some variables. So in my simplifying process, I'm looking at 2 times the square root of 2x to the third. Keep this outer 2. Let's see if we can factor. Now, the number 2 is not a perfect square and does not have a perfect square factor, so it goes back here to the back. But x to the third, if I just took one x away from it, that would leave me x squared. So I have 2x, because the square root of x squared is x, square root of 2x. All right, let's look at the other one. I have 7x square root 18x. I'm going to keep the 7x on the outside and see, I think I can simplify this radical. The 18, it's not a perfect square, but it does have a perfect square factor of 9 with a non-perfect square factor of 2. There's a single x, which cannot be simplified, so I'll just put it back here. It was not even, and it wasn't something I could break down. So that gives me 7x times, the square root of 9 is rational 3, times the square root of 2x, or 21x square root of 2x. Coming back to the problem, I have 2x square root of 2x plus sign 21x square root of 2x. And so I was fortunate, this was rigged. I have some square roots of 2x, those are like radicals. I'm going to add 2x and 21x for 23x. So my answer is 23x times the square root of 2x. Just take these problems one step at a time. If you're competent at simplifying radicals, theirs are not going to be hard. So let's go into the simplifying stage. The first one is 5 times the square root of 48. I will bring the 5 down. 48. I think we've done it before, but maybe we haven't. So let's do some work that I will erase. 48. Well, I know 4 goes into it, and it goes 12 times. That's a perfect square. But I know that there's a factor of 12 that's a perfect square. That's 4 times 3. That means that I have 4 times 4, or a perfect square of 16. And it's the largest. So this is the square root of 16. The other factor was 3. We may have done that before. That gives me 5 times the, take the square root of 16 and get rational 4 times the square root of 3, or 20 times the square root of 3. The next one is 3 times the square root of 32. So bring down the 3. I think we've done 32 a few times. It is 16 times 2. That is 3 times 4 times the square root of 2, or 12 times the square root of 2. These are not like radicals, but we're not going to worry about that. Square root of 75. I think we've done 75 before. You begin to build up memories of simplifying certain numbers. And this is 25 times 3. That gives me rational 5 times the square root of 3. Coming back to my problem, I'm not making it minuscule. There we go. I have 20 times the square root of 3, minus sign, minus 12 times the square root of 2 plus 5 times the square root of 3. So I simply simplify each one of those, and now look at it. This term and this term have square roots of 3, so there are 20 plus 5, or 25 square roots of 3, and then minus 12 square root of 2. There are no like radicals there, so that is my simplified answer. All right, this is kind of a short lesson because this is my last problem. I have each one of these, and I'm going to have to do something. Well, I choose to do this. I choose to call this 5/8 times the square root of 7 plus 2/5 times the square root of 7. So I like to grab this and write it as the coefficient, and grab this and write it as the coefficient. Now these are like radicals, so I'm going to have some square roots of 7. I need to add 5/8 and 2/5. That's okay. I'm going to do my fraction work. I have 5/8 plus 2/5. I have to get a common denominator. 8 and 5 both go into 40. 8 goes into 45 times, and 5 times 5 is 25. So 5/8 is the same as 25/40. 5 goes in there 8 times. 2 times 8 is 16. I keep my common denominator of 40. Write it better. add 25 and 16 for 41. That means that there are 41 40ths, square root of 7. MyMathLab prefers that you write this with the denominator of 40 and put the numerator as rational 41 times the square root of 7. So in other words, you take this and put it back in this form. So these were already like radicals, we just had to get a common denominator. So that's only 10 homework problems. It will reinforce your skills for simplifying radicals, because you must have like radicals to add or subtract, and in order to achieve that, many times you have to simplify.